What do we know from the urban water cycle? How do drinking water supply, wastewater discharge and treatment and the groundwater and surface water systems interact? Welcome to Introduction to Urban Water Cycle. My name is Luc Rietveld, Professor in Drinking Water and Urban Water Cycle Technology. After this lecture, you will be able to understand the key elements of the urban water cycle, the global drivers for urban water management, as well as the importance of water reuse within the urban environment. The urban water cycle consists of technologies needed for drinking water intake, treatment and distribution, as well as wastewater collection, treatment and discharge. To produce drinking water, water is extracted from the underground, so-called groundwater, or from rivers or lakes, the surface water. This source water isn't drinkable and must be treated. The treatment plant consists of different processes depending on the quality of the source and the requirements for drinking water. Afterwards, the water is transported to the city and distributed via a piped network to households, commercial buildings, public entities and small industries. After usage, the water is collected in a sewer system and transported to a wastewater treatment plant where the water quality is improved for discharge into the receiving water bodies as a source for drinking water production. What was the main driver for developing the urban water cycle? The centralized sanitation service finds its origin after the cholera outbreak in London during 1849, when John Snow discovered that there was a real relationship between cholera and the use of contaminated water well. He proved his theory by removing the pump handle from the well, which resulted in a dramatic reduction of the spread of the cholera epidemic. Another example of the benefit of centralized drinking water supply is the number of people dying from typhoid fever in the Netherlands. This number decreased drastically with increasing number of people connected to the centralized drinking water supply system. In the 70s, almost all people were connected and no outbreaks were found anymore. The only new threat is the occurrence of Legionella bacteria in warm water installations. This is especially hazardous for the Netherlands, as here chlorine isn't used for safety disinfection during distribution. Special designs and cleaning procedures have been developed to diminish the risk of. The importance of water supply and proper sanitation is reflected in the words of former UN Secretary General Kofi Annan. No single measure would do more to reduce disease and save lives in the developing world than bringing safe water and adequate sanitation to all. Do we have sufficient drinking water? While in countries like the Netherlands, the water problems are more or less solved, worldwide there is a mountain to climb. In many countries in the world, scarcity is a problem. This can be due to physical causes, such as reduced amount of rainfall, recharging the groundwater aquifers in the rivers, or due to economic factors, meaning that there is no financial capacity to construct and maintain adequate water supply systems. Water scarcity leads to water stress, meaning that the demand for safe drinking water is higher than the availability of water resources with sufficient capacity. Water stress can result in insufficient supply, causing unmet water demands or over-extraction, leading to depletion of groundwater and surface water resources. In the meantime, water demand is increasing. With an increasing population, urbanization and industrialization, more water has to be supplied to cities. These growing demands and demographic changes are also impacting the drainage system and the pollution of the urban environment. The growing water demand requires greater capacity from water sources. These water sources are mostly not found in the vicinities of cities. A clear example is the water supply for Johannesburg and Pretoria, which sources their water from the Vaal Dam. The Lesotho Highlands, approximately 500 kilometers away, entails several dams and tunnels in the mountains to enforce the Vaal River and Vaal Dam in order to secure the water supply to the urbanized area. Water scarcity isn't only a quantity issue, but also a quality one. When sources are too polluted to be a reliable source for water availability is under stress. Therefore, major efforts are made to improve the surface water quality. In the past, the main focus was to remove organic matter from the wastewater, but more recently, advanced nutrient removal is applied to avoid eutrophication of the receiving water bodies. Future emphasis will be laid on the removal of endocrine disrupting compounds such as pesticides and pharmaceuticals to avoid accumulation of persistent organics in the environment. With the increased efforts in wastewater treatment, the effluent of the wastewater treatment plant sometimes obtains a better quality than the receiving water bodies. In these cases, the question arises whether the effluent is the better source for drinking and industrial water supply than some surface water bodies. Several examples exist. The most famous one is in Windhoek, Namibia, where about 25% of the domestic water supply consists of reclaimed wastewater. The effluent of the wastewater treatment plant is extensively treated with ozone, coagulation, flotation, activated carbon filtration, membrane filtration and chlorination. The product can compete with the water obtained from the original source about 300 kilometers away from the city. Another example is the water supply for Dow Chemical in Terneuzen, the Netherlands. The industrial water supply is fed by the wastewater treatment plant of the city of Terneuzen. It appears to be more economical to treat the effluent than to desalinate the salt water flowing in front of the industrial area. In this way, the urban water cycle is closed. Thank you for your attention, and I hope to see you again for the next lecture on the design aspects of drinking water treatment.